This is an entirely different type problem than what we've been looking at as far as what we're doing with the direct variation equation, but it's not anything that's extremely difficult as far as what's actually being done. It's really just kind of one-step equations. It's just a matter of understanding what you're doing and getting everything where it goes. Okay, so what I'm looking for here is this phrase, y varies directly as x. That translates, when I see that, it translates as y is equal to kx. And so this is the phrase that tells me I've got a direct variation equation. Alright, so if y varies directly as x, y is equal to 72, and x is equal to 8, I'm going to do a couple of things. Okay, well, first of all, I know from this statement that I've got this general form of y equals kx. Then they define 2 out of the 3 variables included in this general form. Okay, I've only got 3 variables, y, k, and x. Well, then they just gave me 2 of them here, 72 and 8 for x and y. So I'm going to take those 2 and plug them in my general form, leaving me with only one variable left, the k variable. Then it's just a matter of dividing by 8 on both sides to solve for k. And once I have my k value, then I can write this direct variation equation that they're asking me to write. That's what the A part wants me to do, write a direct variation equation. So I take my k value and go back and plug it in to the original. So the 72 and the 8 are not included in my direct variation equation. I used the 72 and the 8 to find the k. Then once I found my k value, I plugged that back in to the original to get my direct variation equation of y is equal to 9x. All right, now that I have a direct variation equation, I can use that to find different values of y depending upon values of x, or different values of x depending on what y is. So I first have to find my direct variation equation and then see what you're asked to do after that. So the second part of this is to use that and find x when y is 63. Okay, well, I'm starting here with the direct variation equation that I just came up with in the A part. And again, I've been given a value to plug in. So take your 63, plug it in for y, and then solve for x by dividing by 9 on both sides. And when y is 63, x is 7. All right, so you find the direct variation equation or formula, and then you use that along with whatever the given information is in the problem to find your x or your y value. So let's do another one of these together. There's that phrase that I'm looking for, y varies directly as x. As soon as I see that, I'm thinking, all right, I've got a direct variation. Then I have y and x defined, and the first thing I'm doing here is to write a direct variation equation that relates x and y. So to do that, I'm going to start with the general form, y is equal to kx, and then I'm going to plug in my y and my x into this general form. So y is 98, k is what I'm looking for, and x is 14. And so this gives me a one-step equation here. I'm going to be dividing by 14 on both sides to solve for k, and 98 divided by 14 gives me 7. So then I take that back up to my original general form and plug it in for k to get a direct variation equation that relates x and y. Okay, y is 7 times more than x. So now that I have my direct variation equation, I can use this to find y when x is equal to 4 very easily, just by saying y is equal to 7 times 4. So when x is 4, y is equal to 28. Okay, what you're doing here is not a lot different than what you've been doing when you're plugging in x values in a table to graph a line. All right, so Miss Zentek has your classwork assignment for you. Whatever you don't finish in class today, finish for homework tonight, and then we will review that together tomorrow.